Okay, so we have already seen linear programming problems. We'll see now non-linear programming problems. So what is non-linear programming problem? First we'll see the definition. So what definition says? An optimization problem in which either the object function and or some or all constraints are non-linear is called a non-linear programming problem, abbreviated as NLPP. Okay, so what we have here, we can have the objective function or the constraints non-linear, right? Like we can see the examples. If we'll see the first example, z is equals to x1 square plus x2 square plus x3 square minus 2x1 x2 minus 3x2 x3 plus 100. So we can easily see this objective function is non-linear and constraint is x1 plus x2 plus x3 smaller equal 10. The constraint is linear, but the objective function is non-linear, right? So this is an example of non-linear programming problem. Now if we'll see the second example, so what we have here, optimize z is equals to 3x1 plus 4x2 plus 7x3 subject to x1 square plus 2x2 square greater equal 20, and another constraint is 3x1 plus x2 plus 2x3 smaller equal 10. So here we can see the objective function is linear, but the constraint, one of the constraint is non-linear, right? So this is again a non-linear programming problem. Another case is possible where objective function is non-linear, like we can see here, z is equals to x1 square plus x2 square minus 3x1 x2. And the constraint is also non-linear, x1 square plus x1 x2 plus 2x3 is equals to 35, right? So here the objective function and the constraint both are non-linear, right? So these kind of problems, if we want to solve, what we will do here, we will use Kuhn Tucker conditions. Okay, we'll use Kuhn Tucker conditions for non-linear programming problems. So first we will consider a non-linear programming problem with n variables and one inequality constraint, right? So we'll see here, maximize z is equals to f of x1 x2 up to xn. So we are assuming here we have n variables. Okay, so we have a function of n variables which is our objective function, right? So we are optimizing z. Here we are considering the case of maximization, and the constraint, we have only one constraint here. The conditions we are checking is only one constraint. Okay, so subject to g of x1 x2 up to xn smaller equal b, we are considering this as constraint. Of course this will be there, x1 x2 and xn, all xi's will be greater equal 0. Now we'll consider a new function h, which is a function of x1 x2 up to xn. What we are considering this function as? We are considering this function as, this is coming from the constraint g x1 x2 up to xn minus b. Okay, so this is coming from the constraint. So we have assumed this new function. Now, so what are the necessary conditions for maximum? Okay, if we are considering the case of maximization in non-linear programming problem, what are the conditions, right? Necessary conditions which we are going to use to solve our non-linear programming problem. तो वो conditions क्या दिया हुआ है? So as we can see here, जो f है, it is function of x1 x2 up to xn, right? So n variables are there, so that means we can find partial derivative with respect to x1. So first equation will include partial derivative of f with respect to x1, right? Partial derivative of f with respect to x1. Now h is what? G of x1 x2 up to xn minus b, right? So h is also a function of n variables x1 x2 xn. So it is possible to find partial derivative of h with respect to x1. So what we are doing here, we are finding partial derivative of f with respect to x1 and partial derivative of h with respect to x1. Putting in this relation, it should be equals to 0. Okay, then next we are partially differentiating the same equation with respect to x2, then x3 up to xn. So we will partially differentiate this equation with every variable. Okay, then next condition is lambda times h x1 x2 up to xn is equals to 0. Okay, so this is our next condition, necessary condition. And then next one is h x1 comma x2 comma dot 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 comma xn should be smaller equal 0. Okay, so this is coming from, this equation is coming from our constraint. Okay, and lambda should be greater equal to 0 and all xi's also should be greater equals to 0. So these are Kuhn Tucker's condition for maximization problem. But if minimization is there, then what we will do, everything else will be same, and yes, the constraints will be of not less than or equals to type. The only change will be, instead of lambda greater equal to 0, it will be lambda smaller than 0. Okay, so it will be lambda smaller than 0. All other conditions will be same for minimization problem. So this was Kuhn Tucker's conditions for maximization and minimization when only one constraint is given and n variables are there. So now we will see one problem. So use Kuhn Tucker conditions to solve the following NLPP. Maximize z is equals to 2x1 square minus 7x2 square minus 16x1 plus 2x2 plus 12x1 x2 plus 7 subject to 2x1 plus 5x2 smaller equal 105. x1 comma x2 greater equal 0. So here we can see easily, this is a non-linear programming problem. The objective function z, it is not linear. Yeah, constraint is linear, but objective function is not linear. So it is one of the types of non-linear programming problem. So now we'll see how to solve this problem. So first of all, what we'll do, we'll just assume a function f of x1, x2. We can see here we have only two variables, x1 and x2, right? So this is function of x1 and x2. So we are assuming f of x1, x2 is equals to z, right? That is 2x1 square minus 7x2 square minus 16x1 plus 2x2 plus 12x1 x2 plus 7. And hx1 x2 is equals to 2x1 plus 5x2 minus 105. This is coming from the constraint, right? So we have these two equations. Now we know Kuhn Tucker's conditions. We have here only two variables, x1 and x2. So we will differentiate partially del f by del x1 minus lambda del h with respect to x1, right? So we are differentiating first with respect to x1, then we are differentiating with respect to x2. These are Kuhn Tucker's conditions, right? And we have this one also, lambda times h x1 x2 is equals to 0, comma, and this h x1 x2 is smaller equals to 0, which will come from the constraint, right? And lambda is greater equals to 0. So these are Kuhn Tucker's condition for maximization. So if we will substitute all things here, we will partially differentiate f with respect to x1. So what we will have 4x1 इसका 0 हो जाएगा minus 16 plus 12x2, right? 4x1 minus 16 plus 12x2 and h को with respect to x1 differentiate करेंगे तो क्या आएगा 2. So minus 2 lambda, right? तो first equation मिल गया. Second equation, f को now we are differentiating with respect to x2. So what we will have minus 14x2 plus 2 plus 12x1, right? So minus 14x2 plus 2 plus 12x1. Now h को with respect to x2 किया तो क्या आया 5. So minus 5 lambda is equals to 0. So this is our first equation. This is our second equation. Now ये फर्स्ट दो कंडीशन से हमें फर्स्ट टू इक्वेशंस मिल गई. नाउ थर्ड वन, लैम्डा से वी विल मल्टीप्लाई h क्या था अपना 2x1 प्लस 5x2 माइनस 105. So lambda से इसको multiply किया is equals to 0. This is our third equation. And the constraint we have written here 2x1 plus 5x2 minus 105 smaller equals to 0. This is coming from the constraint easily, right? And then x1 comma x2 comma lambda greater equal 0. x1 x2 and lambda will be greater equal 0. Okay. So now we can see अभी हमें ये सॉल्व करना है x1 x2 और लैम्डा के लिए. तो थर्ड इक्वेशन से व्हाट वी आर गेटिंग, प्रोडक्ट ऑफ टू functions is 0. That means either lambda will be 0 or this equation will be 0, right? So from 3 what we will have, lambda 2x1 plus 5x2 minus 105 is equals to 0. This implies either lambda is equals to 0 or 2x1 plus 5x2 minus 105 is equals to 0, right? So either one will be 0 or other will be 0 or both possibilities will be there. Okay, so we will see we can have here two cases. Case 1 can be when lambda is equals to 0, right? So first possibility is when lambda is 0 and second possibility is when the equation is 0, right? When lambda is not 0. So first condition we will see when lambda is equals to 0. So if we will put lambda is equals to 0 in our first and second equation, तो क्या हो जाएगा, 4x1 minus 16 plus 12x2 माइनस 14x2 प्लस 2 प्लस 12x1. x1 और x2 में हमें दो इक्वेशंस मिल जाएंगी, राइट? वी आर गेटिंग टू इक्वेशंस इन x1 एंड x2. दीज टू इक्वेशंस वी कैन सॉल्व फॉर x1 एंड x2. We can use your calculators or we can use our traditional methods to get values of x1 and x2. So एक बार सॉल्व किया हमने तो हमें क्या मिला, x1 x2 का आप these are two equations and two unknowns, so you can use your calculator also. So x1 and x2 का वैल्यू क्या आया, 1 and 1. When we are putting these values in z, so what we are getting, what is z? This we will put here x1 का वैल्यू 1 and x2 का वैल्यू 1. So what we will have, 2 minus 7 minus 16 plus 2 plus 12 plus 7, right? So हमें ये मिला जिसका वैल्यू क्या आ रहा है, 0, बट वी डोंट वांट 0, सो दैट दिस इज ट्रिवियल सोल्यूशन, राइट? दिस इज नॉट feasible solution, this is trivial solution. So this is not feasible solution, so we will reject this case. Now we will check for another one. It is possible कि दोनों में से किसी भी केस में हमें optimum solution ना मिले, but we will check for second condition now. When lambda is not equals to 0, जब lambda not equals to 0 है तो क्या होगा, from 3, when lambda is not equals to 0, then from 3 we will have 2x1 plus 5x2 minus 105 is 0, right? So we are getting 2x1 plus 5x2 minus 105 is equals to 0. Now we will consider first two equations also, जो x1 x2 और lambda की हैं. So now we have these three equations in x1 x2 and lambda. So we can solve these three equations. We can use calculator, 3 equations and 3 unknowns. We will get 3 values here. Now x1 का value we are getting 45, x2 का value we are getting 3 and lambda का value we are getting 100. So we can see now here lambda is equals to 100, which is greater equals to 0, and we'll check all other conditions also. x1 x2 it is satisfying this. What we will have, 2x1 plus 5x2 minus 105. यहाँ पे x1 की जगह पे हमने 45 और x2 की जगह पे 3 पुट किया, तो we are getting minus 10, which is smaller than 0, right? So satisfying the conditions. So our x1 x2 and lambda are satisfying all the conditions. Now we will see value of z. What we are getting after substituting x1 is equals to 45 and x2 is equals to 3 in z. In objective function we are getting value 4900. So this is our z max. So these set of solutions, x1 is equals to 45 and x2 is equals to 3, are satisfying all the necessary conditions for Kuhn Tucker, right? Kuhn Tucker's conditions, and we are getting value of z max 4900. So this is optimal. So thus the optimal solution will be x1 is equals to 45 and x2 is equals to 3. We have seen in simplex optimal solution क्या होता है, जिसके लिए हमें या तो मैक्सिमम मिल रहा है या तो मिनिमम मिल रहा है. तो यहाँ पे हमें मैक्सिमम वैल्यू मिल रहा है x1 is equals to 45 के लिए and x2 is equals to 3 के लिए. So this is our optimal solution.